Hello students, you are welcome back to Dr. Oji's tutorial class. This is a follow-up to the previous lecture video that was given to you previously. So in this video, we'll be talking about how to sketch the graph of a function and how to determine its range. But don't forget, we stopped at quadratic functions in the previous video. So we are continuing with quadratic functions. We want to look at how we sketch quadratic functions. If it could be recalled that for us to sketch a function, whether quadratic or otherwise, we will first of all need to know the point of x and the point of y coordinates. Okay, and as far as the quadratic functions are concerned, this one will give us a minimum point. How? Why? It's going to give us the minimum point because the coefficient of x squared here is 1 and 1 is more than 0. So anytime your value of a, if you go back to the note I gave to you, the video we had last time, a is positive here because it's 1. So since it is 1, using as squared plus bx plus c, that's the general form of quadratic equation where a is not 0. We are taught that. So since a is not 0, it means comparing this with this, our a is 1. Can compare a is 1 here, b is minus 2, c is minus 3. So since a is positive, this particular function will give us what? A minimum point. So that means f of x equals to x squared minus 2x minus 3 will give us a minimum point. Minimum point. So it will give us a minimum point. Yes. Now, what are the points? How do you now know the point? Fine. You could use what we call complete square method there to know how you can get a complete square from here. Because we need to get a complete square. It is that complete square that will give us the point at which our minimum exists. So that means, recall, your complete square method is just what? Just say x squared minus 2x plus, half of this, minus 2 all over 2. Sure, you can remember that square. That's the method. You have been taught this, but if you have forgotten this, just a reminder. So x squared minus 2x plus the coefficient of your x here, minus 2, half. This 2 is a constant. You are using this, not this 2 that we are not using this 2 to divide it to. This 2 is a constant, half of what you have as your coefficient there. So it will be what? It will be x squared minus 2x, plus 1. It's plus 1. Because this minus 2 over 2, that's minus 1. Minus 1 squared is plus 1. Fine. So that means for us to get a perfect square, we are going to add 1 to this particular problem. Okay, so adding 1 to it now will give us a perfect square. So that implies that we can have x minus 1 square. That is what because this thing now will give us x minus 1 square. Can you still remember that at all? Fine. That is going to give us x minus 1 square. And we have obtained what? X squared minus 2x plus 1 from x minus 1 square. How do we now get minus 3? Don't forget, x minus 1 whole square is expansion give us what? Plus 1. Now, but originally, minus 3 is supposed to be there. It's supposed to be there because you have excluded minus 3 from the equation here. So that means if we now have x minus 1 whole square giving us x squared minus 2x plus 1, what are we going to add to this particular one, this expression, that when we add this, add that thing to this plus 1, it will give us back minus 3. Again, when we perform the operation of completing square, we've got x squared minus 2x plus 1 gives us x minus 1 whole square. Fine. Now, how do we revert to the original equation? That means we need to add something to this plus 1 to give us minus 3. What are we going to add to plus 1 that is give us minus 3? That's minus 4. So that means I can now say that the whole of this now will be x minus 1 squared minus 4. That's the whole of this expression now has become this. So that implies that the point of the minimum will now be, since a is positive, obviously, the minimum point on the graph will be at 1 and minus 4. How? Fine. If you equate x minus 1 to 0, x minus 1 equals 0, x equals to 1. Then minus 4 is just a constant. So, because this is the equation of a parabola, you can still remember how you are taught in parabola to get the hk points of the parabola, minimum point. You just equate what you have here in this bracket to 0. You pick x minus 1 equals 0. What value we get as value of x is a point for x. Then this other one, minus 4, is just the equivalent point of y there. So now, having done that, we have gotten the minimum point now. Okay, we move. That's the minimum point. That's the minimum point at which our graph will be found. We have got minus 1 and 1 and also our f of x as given x squared minus 2x minus 3 can be factorized. Yes, we can factorize it. How? Okay, by factorization method, we multiply x squared by minus 3. That would what? Minus 3x squared. And now look for the factor of minus 3x squared. That would be minus 3x plus 2x. So minus 3x, no, that will give us minus 2x plus x. Does that work now? Yes. So minus 3x plus x will give us minus 2x. So that means we can factor out this and replace minus 2x by minus 3x plus x. So that we have x squared minus 3x plus x, then minus 3. So now I have x into x minus 3 plus 1 into x minus 3. So which will give us what? X plus 1, x minus 3. So now we have factorized that expression. So for f of x equals to 0 now, for f of x equals to 0 now, for f of x equals to 0 now, we have x plus 1 equals to 0, x equals to minus 1. This, the x minus 3 equals to 0, x equals to minus 3. No, x equals to plus 3, sorry. X equals to 3. Okay? Now we have gotten that. That means x is equal to minus 1 or 3. X equals to minus 1 or 3. That means this. What is the meaning of this now? Fine. Let's write what this means. Don't forget, we started with using complete square method to know the minimum points. And how do we know it's going to be minimum point? Because our A is positive. When your A is positive, obviously the graph will give you a minimum point. So now, this means that the graph cuts the x-axis at those points. It cuts at minus 1, 0 and what? And 3, 0. Yes. You know we have our x is equal to minus 1, 3. So that means how do we now sketch the graph? Fine. Very simple. This is minus 1, because we have x minus 1. Let's say this x equals to 3. Now, where did the minimum point occur? It occurs at what? It occurs at 1 and minus 4. Are we still together? Is that what we're? Yes. So nx is 1, y is minus 4. Fine. So let's you know this is x. This is x. This is the point of origin. This is x-axis, y. You know that already. So let's say 1 is somewhere here, 2 is here. So let's move down here. Let's say somewhere here. Okay. Now, and our y is minus 4. Fine. Since this is y negative, y positive. Let's say this is minus 1, minus 2, minus 3, minus 4. We just, it's sketching. We are sketching. It means yes, something here. So that means correspondingly, we have 1 and minus 4 here. 1 for x, minus 4 for y. So obviously, what's the problem now? It now connects. So it now connects. That's all. It now connects. That's all. So this is the graph we are asked to, we are asked to plot. That's the graph we are asked to plot. I hope this is understood. It's not difficult at all. So don't forget again, click on the notification button so that anytime I produce new video and post it to you, you'll be equally notified. Thank you.